Now to discuss about thermodynamic property. Which is thermodynamic property? Thermodynamic property is a property of chemical equilibrium which is a function of temperature. The equilibrium rate constant. The equilibrium rate constant, which is a function of temperature only, is known as thermodynamic property. Okay, so Kp and Kc is a function of temperature only, but Kx is a function of pressure and temperature, so it is not a thermodynamic property. Now the relation, now we discuss that relation between Kp, Kc and Kx. Okay, so we know that Kp is equal to P0 whole to the power gamma dot Pd by P0 over delta divided by Pa by P0 whole to the power alpha dot Pb by P0 whole to the power beta. So from the ideal gas equation we know that PV समान nRT. ठीक, all right, from ideal gas equation. Okay, now for if we the mixture of gas, there is a many mixture of gas and the volume of the gas is constant, so V is constant here and temperature is also constant, so here variable is pressure and number of moles. So Pi for ith, Pi V समान Ni RT plus Pi समान Ni by V, and we know that concentration समान number of moles divided by volume, so Pi equals to Ci RT. Now this formula we will put in the equation 1, then Kp will be Cc RT divided by P0 for gamma dot Cd RT P0 delta divided by CART per P0 alpha CB RT P0 beta. Now Kp equals to CRT full to the power gamma CDRT full to the power delta divided by CART whole to the power alpha T whole to the power beta. So 1 by P0 equal to what will be alpha gamma plus delta minus alpha minus beta. Okay, now CC gamma CD delta divided by CA alpha dot CB beta. If we taken out RT, then it will be RT by P0 to the power gamma plus delta minus alpha plus beta. And if we divided all by C0, CD to the power CD by C0 whole to the power delta divided by C by C0 whole to the power alpha to CB by C0 whole to the power, then what will then it will be we divided all by C0. We divided all by C0, so we must be multiplied to C0. So if we multiplied it, then what will be? Then it will be cross C0 whole to the power gamma plus delta minus alpha plus beta. So we must include the C0 term into this C0 RT divided by P0 whole to the power gamma plus delta minus alpha plus beta. So, and this all term is known as Kc, we know, into C0 RT whole to the power P0, and this term is known as delta in. Then what is delta in? Then delta in is equal to gamma plus delta minus alpha plus beta, which is this is product stoichiometry minus reactant stoichiometry. Okay, now it is what will be the relation between Kp and Kx. So we know that Kp equal to Pd by P0 whole to the power delta into Pc by P0 whole to the power gamma divided by Pa by P0 whole to the power alpha into Pb by P0 whole to the power beta. Now from Dalton partial pressure law, we know that Pi equal to Xi into P. Here P is the partial pressure and this P is the total pressure, and this Xi equal to mole fraction. So this equation we have to put into this. So equals to Xd divided by P0 divided by delta D, Xc into P0 gamma divided by Xa divided by P0 for alpha Xb P0 beta into what it will be. See, we replaced this term into xd into p. So p term is here, and this will be gamma plus delta minus alpha plus beta. So equal to xd into xc delta gamma divided by xa alpha xb beta into p by p0 whole to the power gamma plus delta and this term is known as kx into p by p0 and this is known as delta n. So the relation between kp and kc is this: kp समान kc into c0 rt divided by p0 whole to the power del n, and between kp and kx is kp equal to kx into p by p0 whole to the power del n. In many competitive exam, many students face a question that when ka is equals to kc, this see that ka is the equilibrium constant of activity coefficient and kc is the equilibrium constant of concentration factor. Okay, now what is ka? So we know that ka equals to ad divided by a0 whole to the power delta or ac a0 whole to the power gamma divided by a by a0 whole to the power alpha or ab by a0 whole to the power beta. Now we know that activity coefficient equal to concentration into F, and this is known as activity and this is concentration and this is activity coefficient. Okay, so you have used this formula in this equation. Now K equals to CD into what it will be? It will be FD divided by A0, and A0 is also C0 into F0, so this is C0 into F0 and this is CA into FA and this is C0 into F0 the whole to the power delta alpha into CC into FC divided by C0 F0 gamma into CB FB divided by C0 F0 whole to the power beta. Now we separate all CD divided by C0 over delta into CC by C0 whole to the power gamma divided by CA divided by C0 alpha CP divided by C0 for beta. Okay, into FD whole to the power C See here, you can neglect this F0 term. Now question is that why? Because A0 is activity coefficient at 25 degrees centigrade or at standard condition. So we know that at standard condition and it is A0 equal to 1 mole per liter, the value. So here F0 equals to 1 because the standard value of A0 is applicable in dilute solution. So F0 is 1, and we know that for dilute solution F0 is always 1. Okay, next, so Fd delta into Fc gamma divided by Fa alpha into Fb beta. Now this is Kc into Fd delta Fc gamma divided by Fa alpha into Fb beta. Now this is the relation between Ka and Kc. So when Ka will be Kc, now Ka will be Kc when this value is 1. So when Fd into Fc divided by Fa, Fd delta gamma alpha Fb beta equals to 1, and this will be 1 only for dilute solution. So for only dilute solution Ka equals to Kc. This Ka, Kc, Kp, Kx all terms are unitless and dimensionless. Now there is another question. When Kp equals to Kc, now we know the relation that Kp equals to Kc into C0 RT by P0 whole to the power delta N. Now Kp is equals to Kc when this factor is 1. So when this factor will be 1, this factor will be 1 in two conditions. The first condition is when delta n will be 0. So when delta n will be 0, now delta n will be 0 when the reactance stoichiometry equals the product stoichiometry. As for example, for this reaction, for this reaction delta n equals to 1 plus 1 minus plus 1, so 0. For this reaction is Kp equals to Kc. And second condition is if we consider that C0 equals to 1 mole per liter and P0 equals to 1 atmosphere, and temperature equals to 1 R. That means 1 by 0.0821, that is Kelvin, equals to near about this value is 12 Kelvin. So why we do this? Because when C0 equals to 1 mole per liter, P0 equal to 1 atmosphere, then it is Kp equals to Kc into RT to the power del N. So if we do that Kp equals to Kc into 1 whole to the power del n, then any values of del n, this factor will be 1. So now if t will be 1 by r, then r cuts r, and then this value will be 1. Then r means 0.0821. This value is in later atmosphere, and in the chemical equilibrium, especially in heterogeneous equilibrium, we put the value of r in liter atmosphere unit. So and 1 by 0.0821 value is nears about 12 Kelvin. So at 12 Kelvin temperature, Kp equals to Kc, or when del n equals to 0. Now considering this reaction into plus 3H2 gas equilibrium with 2NH3. Now if we undergo some condition that if the reaction is reversible, then what happened? We reverse the reaction. 2NH3 equilibrium with into this equilibrium constant we considering Kp, and this equilibrium considering Kp test. Then if we reversed a chemical reaction, then what will affect what will change in the chemical equilibrium constant? So in this case, Kp will be partial pressure of NH3 divided by P0 to the power 2 divided by partial pressure of N2 divided by P0 whole to the power 1 to partial pressure of H2 divided by P0 to the power 3. And for this reaction, Kp dash equal to partial pressure of N2 to partial pressure of H2 whole to the power 3 divided by P0 divided by partial pressure of NH3 by partial pressure P0 whole to the power 2. Now you see that if we divided it by 1 divided by P of NH3 divided by P0. And this is Kp. So if we reverse the reaction, then Kp of the new reaction is the reciprocal of Kp, the old Kp. Okay. Now if you multiplied this reaction, then what will affect in Kp? So we multiplied it. 2 into plus 6 H2 into 4 NH3, and for this reaction it will be Kp double dash. We consider this equilibrium rest constant, then it will be P NH3 4 divided by into NH3 divided by P0 divided by P0 2 PH2 by P0 6. Now see that in this reaction and this reaction, see that carefully, that if it is a square form, this reacts this equation, this is the square form of this. So H3 by P0 square divided by Pn2 by P0 into PH2 by P0, and this is what? Kp. So this is Kp square. So Ke double dash equal to Kp square. Okay. Now if we divided this into plus 3H2 to 2NH3 equal to Kp equals to if we divided the one number equation by 2, so the newly reaction will be half into plus now for this reaction Kp triple dot equals to partial pressure of NH3 by partial pressure of into half into partial pressure of H2. Look carefully that this reaction, this is the this equation is the square form of this. So and this equation is the square root of this equation is known as Kp. So if we divided it, the equation, then it will be Kp dash equal to Kp whole to the power half.